the next disaccharide that we are going to study is maltose. Now maltose on hydrolysis, it produces 2 units of alpha-D-glucose. Therefore, it comes under disaccharides. Okay, now let's look at the formation of glycosidic linkage in maltose. Now what happens is when 2 alpha-D-glucose join together, first you need to know how to write down the structure of alpha-D-glucose. Okay, you have got 2 units of alpha-D-glucose. Number the carbon atom, this is your first, second, third, fourth and the fifth carbon atom. Here also 1, 2, 3, 4 and 5. Now what happens is, again, distribute the OH and the H groups. On the first carbon atom in alpha, you have OH on the right hand side, therefore OH will come at the bottom, H will come on the top. On the second, you have again OH on the right hand side, therefore OH at the bottom, H. And third one, OH is on the left, therefore on the top, and then you will have your hydrogen at the bottom. And on the fourth carbon atom, OH is on the right, therefore at the bottom, and then your hydrogen, and then you have CH2OH, and then hydrogen. Here also alpha, same as this one, OH on the right, therefore it come at the bottom, and then OH on the bottom, H, OH, H and CH2, OH and then H. Now what happens is, these two will join together. This is alpha D again. Okay. Now these two will join together by eliminating a water molecule between C1 and C4. C1 and C4 of this glucose unit. So C1, C4 linkage is formed. The C4 and C1 both have OH, OH. Now from there, you have to remove a water molecule, and these two will join through this oxygen atom. And you will get a product where everything that it's written, OH, H, and then you have OH, H, CH2, OH, and then H. Now this linkage is called as glycosidic linkage. And this is maltose. 2 alpha-D-glucose units join together to form maltose. Now if you are asked whether it is reducing or non-reducing sugar, you have to look for carbon which carries an OH, an OR, and hydrogen atom. If this group is present, that is the hemiacetal group, then it indicates that it is a reducing sugar. So in this case, the first carbon atom carries a hydrogen atom, carries a hydroxyl group, carries an OR, ether group, therefore it is a reducing sugar. So this is about disaccharide. The last disaccharide that we are going to study is lactose. Now lactose is made up of 2 units of monosaccharides. One is beta-galactose or beta-D-galactose, and the other one is beta-D-glucose. Now you might find this new galactose. This also carries a molecular formula of 6,6H12O6. Now let me explain the difference between these two by first writing down the structure. I'm going to write down the structure of glucose. Glucose is a 6-membered ring again. Now this is your first, second, third, fourth, fifth carbon atom. Now this says beta. Beta means OH on left of first carbon atom of C1. Therefore OH on the top and then hydrogen at the bottom. On the second, OH is on the right, therefore at the bottom, and then hydrogen. On the third, OH is on the top and then hydrogen, OH, H, CH2OH, and then hydrogen atom. Now in the case of galactose, which is also a 6-membered ring, now the difference lies at the C4. At C4 you have OH on the right hand side of, in the case of glucose, whereas in the case of galactose you will have OH on the left hand side, therefore OH on the top and then hydrogen. Rest is all same. Beta means OH on the left hand side, therefore OH on the top and then hydrogen, OH, H, H, OH, and then CH2OH, and then your hydrogen. So beta galactose and beta D-glucose can be called as C4 anomers. So when you change the position of OH on the C4, you will get, if the OH is on the right, you will have beta D-glucose. If the OH is on the left, you will have beta D-galactose. So that's the difference between the two. Very simple. Only thing is you have to flip this to position. H will come at the bottom, OH will come on the top. Now a glycosidic linkage will be formed between these two and you get the lactose. Now for that again, C1, C4 linkage is formed. Now how does that happen is, this is the C1 and this is the C4. Now these two will react in such a way that a water molecule is eliminated and these two are combined through this oxygen atom. So you will get a compound where an oxygen link is formed between these two rings. Rest just copy it down. You have OH, H, and then H, OH, and then OH on the right, on the top, and then hydrogen, and then you have CH2OH, H, and here hydrogen. Here you have hydrogen, and then OH, H, and this is your H, OH, H, OH, and then CH2OH. Now this is called as lactose, which is also known as milk sugar because it is present in milk. And this is your beta D-glucose, and this is beta D-galactose. So you can see that when a glycosidic linkage is formed between C1 of beta D-glucose with C4 of beta D-glucose, sorry, C1 of beta D-galactose with C4 of beta D-glucose, you get lactose. So this is about the formation of glycosidic linkage. This is the glycosidic linkage in maltose. Now if you look at the reducing character of galactose, you have to look for the carbon atom which carries a OH group, a hydrogen group, and an ether group, OR. If these three are present on any of this carbon atom, it is said to be reducing sugar. So we'll take this first carbon atom. On this first carbon atom, there is a presence of OH, there is a presence of H, and there is a presence of OR group. Therefore, it is a reducing sugar. Now that we are done with monosaccharides and disaccharides, the next one is polysaccharides. Let's recall what is polysaccharides. Polysaccharides are the carbohydrates which produces more than 10 units of monosaccharides on hydrolysis. Units of monosaccharides on hydrolysis. Under polysaccharides, we are going to study about the starch, and then we are going to study about cellulose, and then the glycogen. So we'll go one by one. Let's first start with the starch. Now starch is made up of two components. The first one is amylose, and then the second one is amylopectin. Two components, these are the two components of starch. Now amylose and amylopectin both are made up of alpha D plus glucose. Many alpha D glucose units come together to form starch. Now there are two ways of branching of alpha D glucose units. That is, you have amylose, in which you have a straight chain of alpha D glucose units, whereas in the case of amylopectin, you have branch chain of alpha D glucose units. So amylose comprises of about 15 to 20% of starch, whereas amylopectin comprises of 80 to 85% of the starch, and amylose is water soluble, whereas amylopectin is water insoluble. It is unbranched units of alpha D monosaccharides, whereas in this case it is branched. So branching takes place in the amylopectin. Amylopectin, C1 and C4 linkage takes place, whereas in the case of amylopectin, there are two types of linkage, that is C1, C4 and C1 and C6 linkage. So that's the difference between amylose and amylopectin. Amylose is a single straight chain of alpha D glucose units, whereas in the case of amylopectin, it is a branch units of alpha D glucose units. And amylose is water soluble because it has more tendency to form intermolecular hydrogen bonding with water, whereas in this case, due to branching, there is less tendency to form intermolecular hydrogen bonds with water, therefore it becomes insoluble in water, whereas amylose is soluble in water. And in the case of amylose, there is C1, C4 linkage only, whereas in the case of amylopectin, C1, C4 and C1 and C6 glycosidic linkage is formed. So that's about the difference between amylose and amylopectin. Now let us look at the structure of amylose and amylopectin. Now look at the glycosidic linkage formation in amylose. Amylose and amylopectin both are made up of alpha D glucose units. Now in order to show the linkage, let us first draw some of the alpha D glucose units. Now you can see that without knowing the structure of glucose, it is not possible for you to learn amylose, amylopectin, fruit sucrose, lactose, maltose. All that depends upon the structure of glucose and fructose. So it is very important that you should know these structures. Now alpha means, again, OH is on the right, therefore it will come at the bottom of the first carbon atom, OH, H. And then you have on the second OH on the right, therefore at the bottom. On the third carbon atom, it is on the left, therefore it comes at the top, and then your hydrogen, and then you have fourth carbon atom, 1, 2, 3, 4. On the fourth carbon atom, OH is on the right, therefore at the bottom, H, CH2OH, and then H. Similarly, in this case also H, OH, OH, H. We know that alpha has two OH together, and then you have OH on the left, third carbon atom, therefore on the top, and then hydrogen, OH, H, and then you have CH2OH, and then hydrogen. Okay, now one more, hydrogen, OH, and this OH, H, OH, H, CH2OH, and then hydrogen. Now here, formation of glycosidic linkage takes place between C1 and C4. C1, C4 glycosidic linkage is formed. So C1 of first glucose unit will react with the C4 of the next glucose unit, and it forms a oxide linkage. C1, C2, C3, C4. Here also C1, C2, C3, and C4. This OH on the C1 and this OH on the C4 will react together, and a water molecule is removed. And these two are joined through this oxygen atom. So it is an oxide linkage, which is also called as glycosidic linkage. Similarly, from this two you are going to eliminate a water molecule, and these two combines together through this oxygen. And this again will react with the fourth carbon atom of the next glucose unit, and it forms a linkage. Here also, this oxygen will form a linkage with the previous glucose unit. So this goes on and on. So you can write it as now a glycosidic linkage through this oxygen atom, here also. So you can see that the glucose units are joined together in a straight chain. So this is the structure of amylose, which has alpha linkage. The linkage is between alpha D glucose units, therefore alpha linkage. So that's about the structure of amylose. Now if you are asked whether they are reducing or non-reducing sugar, now for that you have to again look for a carbon atom which have a OH. As I said earlier, if it carries a OH, H and OR, then it is said to be a reducing sugar. But in this case, none of the carbon atom carries these groups. Look at this carbon atom, it has H, it has OR, but it does not have OH on this carbon atom. Similarly, let's take this carbon, H, OR, but it does not have OH, therefore amylose is a non-reducing sugar. So this is about amylose. Now let's go to amylopectin, where you have branching between the first carbon atom and the sixth carbon atom of the next chain. The next component of starch is the amylopectin. In this case also it is made up of alpha D glucose units. The difference is here branching takes place, therefore there is C1, C4 linkage, and also there is presence of C1, C6 linkage. You see that these two, the first carbon atom of this and the fourth carbon atom of this glucose units, you are going to remove a water molecule from this two, and it forms a glycosidic linkage. So I can also write this as these two linked through this oxygen atom. Now this two again, from this two, C4 and C1, you are going to remove a water molecule, a glycosidic linkage is formed. From here also, water molecule is removed and a linkage is formed. Now this is C1, C4, here also C1, C4, here also C1, C4, And again, this goes on and on. Here also you have n number of glucose units joining together. Now, in this case, what happens is, this is the C1 and this is the C6. Now, C1 and C6 OH groups, from this, you are going to remove a water molecule. When you remove a water molecule from this, if you remove this water molecule, this O will form a bond between these two. That's how a glycosidic link is formed between C1 and C6 of these two glucose units. So branching takes place between these two straight chain through C1 and C6 carbon atom. So a linkage, C1, C4 linkage is formed, a linkage of C1 and C6 linkage is also formed. So that's about the glycosidic linkage formation in amylopectin. You see that all are alpha linkage. That is, all glucose units are alpha D glucose units. If you look at the reducing character of amylopectin, you will see that there is no carbon atom which carries OH, R and OR and hydrogen. Because of absence of such carbon atoms with an OH group, an OR and hydrogen atom, it is said to be a non-reducing sugar. So this is about the glycosidic linkage formation and reducing character of amylopectin. Now the next polysaccharide after starch is cellulose. Cellulose is found in the cell walls of the plants, and it is made up of beta D glucose units. Now to show the formation of glycosidic linkage in cellulose, first you need to know the structure of beta D glucose. Okay, let's say this is one beta D glucose unit, and this is another beta D glucose unit. First carbon, second carbon, third, fourth, fifth and the sixth one. Here also first, second, third, fourth, fifth and the sixth one. First, second, third, fourth, fifth and the sixth one. Now beta means OH is on the left hand side, therefore OH will always come at the top, and then hydrogen. Second, you have hydrogen on OH on the right hand side, therefore OH at the bottom, H. Here OH will come at the top, H, OH, H, and then you have CH2OH and then the hydrogen atom. In this case also, since this is all beta, again you will have OH on the top, H, and on the second OH at the bottom, H, H, OH, OH, and then H, and CH2OH, and then hydrogen. Here also you have OH on the top, H. That's why we are writing in this way, and then OH, H, OH, H, OH, H, then you have CH2OH on the top and then the hydrogen. Now because this is in the beta form, how does the formation of glycosidic linkage takes place is, now C1, C4 linkage takes place, C1, C4 linkage. Now how does that happen is, this OH and this hydrogen is removed in the form of water molecule, and these two are linked through this oxygen atom. Similarly in this case also, this OH and this hydrogen is removed in the form of water, and these two are linked through this oxygen. So you can see that the oxide link is formed between the first carbon and the fourth carbon atom of the next glucose unit. Here also this again goes on. It is not just 3, you have got many more glucose units coming together. Here also this O is linked to the next unit of the glucose. Now I'm going to show the linkage here. Now water molecule is removed, and you just have to join this two through this oxygen atom. Okay, here also So you can see that here beta linkage is being formed, and the linkage takes place between C1 and the C4. So this is about the glycosidic linkage formation in cellulose. Okay, then the final polysaccharide that we are going to study is glycogen. Okay, this is number 2. Second polysaccharide, and the third polysaccharide we are going to study is glycogen. Now glycogen has the structure similar to amylopectin, which we have already done, therefore I'm not going to write down the structure of glycogen. It is similar to amylopectin, only thing is it is more or highly branched than amylopectin, and it is also called as animal starch. So that's about the polysaccharide, and also we have come to the conclusion of carbohydrates, the first part of this chapter. In today's class we discussed about the preparation and structure of fructose, then we discussed about disaccharides, that is sucrose, lactose and maltose, and then we went to the polysaccharides, under which we discussed about starch, cellulose and glycogen. And those chine there is in a dupache, and there is in an also khari chilena, thambo the fructose key structure, the preparation condensime, and then disaccharides namola, thambo the sucrose chile, sucrose the namola glycosidic linkage condense form chile, sucrose the kharis key segurana, alpha D glucose, beta D fructose key. And then co-reducing heme, co-reducing marwa, Karichelina, Pokinona, carbon kana OH, OR, H, the Sangi Midu Samana, non-reducing sugars. Then also maltose chile, maltose the Karik is securana, alpha glucose, alpha D glucose, ni yamdotine, and maltose charge. Then also lactose, lactose the Karik is securana. Beta D galactose, beta D glucose, beta D galactose, glucose ni gikima la keba karelena C4 kana OH H ki position ni keba latani galactose glucose ni rayuwa dusche. Then also polysaccharides. Polysaccharides namola starch but the starch the component ni is amylose amylopectin. Amylose amylopectin ni la keba karelena amylose namola C1 C4 linkage chupuchiche amylopectin namola branching chi yoores. This in C1, C4, Yamdo Lagi, C1, the C6 linkage carriers. This in a Karela Kipa Dogon, amylose, the water soluble chair, amylopectin, the water insoluble value to Sherma. Then also cellulose, cellulose, the Karik is beta D glucose, and linkage, Sama Karirana, beta linkage chair. Then also glycogen, glycogen, the structure, the amylopectin, the chipperes. Kebar Karela Dolana, Korangi, Nana branching, the Mairis, the chipperes, to Chile. Those chaining also carbohydrates starch, and it jimmers in the proteins, the vitamins ni. So with this we are done with today's class. In the next class we are going to do proteins and vitamins. Thank you.